First of all, I'll go to paper number 1. Now, any question which anybody is having in paper 1, he can put up his point. I will briefly go through the discussion. You can write in the chat box anything you want to discuss in paper 1.
Sir, fifth question.
Fifth question.
Yes, sir.
Okay. Yeah, in fifth question, you have to just apply. I'll go through the concepts. Like the rod was being given, which was left from a vertical position. And if you leave it from t is equal to 0, it is sliding. And at a general theta, he's saying find out the velocity of center of mass and the angular velocity. So the concept was this point is having a velocity downward. So draw a perpendicular like this. This guy is having a velocity left, draw a perpendicular like this. You'll get this point as your ICOR. Take angular velocity about this point as omega as a function of theta. Now just apply conservation of energy. Your center of mass was initially at a height of L by 2, right? And now it is at a height of L by 2 sine theta. And whatever is gone is half of I ICOR into omega as function of theta ka square. That is equation number 1. Now, I think it is very clear to all of you that this point is known, right? This distance is L by 2. This distance is L by 2. Similarly, you can write this point and you can find out the distance between these 2 points, D. So you know that I ICOR will be equal to ML square by 12 plus M into D square. These coordinates are like these. This is L cos and L sine. I am treating this direction as my positive X and this as my positive Y. And this is L by 2 cos and L by 2 sine. So by distance formula or whichever way, you can find out D square. Substitute here, you will get omega. So answers to the question are omega as function of theta done by these 2 equations. And if you want to find out VCM is d omega. Because from ICOR, if you just apply the concepts of r omega, you'll get the velocity of any point on the rigid body. So it is d into omega as function of theta. One thing that, these are the answers to the question. One thing that you should be clear about is, while he is asking the question at theta is equal to 30, technically you should have been clear that the contact is not getting lost. So an intelligent student will always think this way, sir, fine, I have verified that for any theta that is up to theta is equal to 30, this contact is not getting lost. So I was able to write this solution because I knew this thing that theta is, for any theta, it is not leaving contact. And if somebody wants to verify that, what is the technique? You can take normal reaction here. You can take normal reaction here. You can take weight here. And then you can write your equations about ICOR again. I mean, treat this point as ICOR. Write the torque equation about this point, and the torque is provided by this mg. That way you can find out the value of alpha. Once you get the value of alpha, you can find out the acceleration of center of mass in the left and the vertical direction. And once you know the acceleration of CM in the leftward direction, write the force equation and find out this normal reaction. This is just a verification that somebody would have done. But in this question, because the options are very simple, you need not do this. This is just for your clarity that I have done. And next question. Yeah, next, Yash.
Sir, 11 can C and D option.
I didn't got it. It is question number 11?
Yes, sir, 11.
Yeah. Let me just go through 11. Yeah, this was a nice question. There is a switch to inductor. There is an inductor, resistor. Then he says that fine, I have a switch here also, EMF and a resistance R. I'll go through this. This is 2L, this is L, this is R, this is E, this is R, this switch 1, switch 2. Initially, at t is equal to 0, this guy was closed, this was open. So system was having a current of E by 2R because the inductor would act like a short-circuited wire. Now, as you close the switch at t is equal to 0, so just after t is equal to 0, what happens? What happens is I have got an inductor. I have got an inductor and a resistor here. And I have got a EMF and a resistance here. So I've got a R, I've got a R, I've got a 2L, I've got a L, I've got a E. Now, we know that immediately the current cannot change in this inductor. So what will happen just after t is equal to 0 also, the current flow will be like same only. and what is the amount of current which will flow? That is E by 2R. Luckily, in this guy, it will be 0 ampere at t is equal to 0. Now I'll say what happens at t is equal to t. So at general t is equal to the inductor, resistor. It's just about writing that term carefully and you'll get your answer like simply. What I'll do is, at this stage, if I assume the current in this guy to be X, so there is an EMF which is 2L dx by dt. If I assume the current here to be Y, it is this EMF L dy by dt. Y is going like this. And the net current here is X plus Y. Net which is coming out is X plus Y. This resistance is R. Now you know that at t is equal to t, all the EMFs are equal. So 2L dx by dt is equal to L dy by dt from here to here and plus Y into resistance R. I am assuming currents to be X and Y. And that is also equal to the EMF of this guy, that is E. And then again there is a minus. So minus X plus Y multiplied by R. This is the general equation, general state. And we know that as time tends to infinity, rate of changes in both the EMF will become 0. So as t tends to infinity, dx by dt tends to 0 and dy by dt tends to 0. So what happens in this equation? Y as such will also become equal to 0. From this equation, this term 0, this term 0. So y will be equal to 0. Y equal to 0. So x ka value from this equation will come out as E by R. So E by R. So you know the value of all the terms, all the currents at infinity and 0, everything is known. So I think if you look into the options of the question, A part was what will be the current through the switch 2? So switch 2 is X. So X is E by R. So the option is correct. So switch 2 ke baad L naught. E by 2R is wrong. A is correct. B is wrong. C is good. He says what is the total amount of charge that will cross through the resistance R naught. Now you're talking about the charge through this guy. And the current here is Y. So basically in C and D part, you're talking about integral of Y dt. Right? From 0 to infinity. Now tell me, if I use integral Y dt in any of these equations, just look into this equation carefully. Just multiply by dt and take integral sign. So what LHS becomes, I'll write here. If you take integral, it becomes 2L dx. So that becomes delta x. That is equal to L dt. That becomes delta y plus R integral y dt. So R is R and integral y dt is my answer. So if I call it unknown, let's say some unknown, put that unknown here. So answer of C and D part will come like unknown is equal to 2L delta x minus L delta y divided by R. This is the answer of C and D. Now the question is what is delta x, what is delta y? You know the situations. I'll substitute here. Where? What is the value of delta x? Now x is the current in the topmost guy and the final value is E by R. Initial value is 0. So delta x is E by R minus 0. And what about delta y here? Delta y is this guy. Final value is 0 minus. What is the initial value here? It was E by 2R. So minus E by 2. So you substitute delta x, you substitute delta y, you'll get the value of unknown. So out of C and D, C is coming out and D was in. So that is how you have to observe the question. Next one. Paper 1. Any other question in paper 1 to anyone in the class?
Sir, 13th one.
13th question. Okay. That was nice. Just you have to write the impulse in the angular impulse equation. This guy comes here, strikes and comes to a state of rest. Now there is a weight which is acting. There's a normal reaction which will act. And because it is moving anti-clockwise, there is a kinetic friction which is mu into n. Now this guy is impulsive. This guy is impulsive. Forget about this guy. Now just write the impulse equation directly and I'm taking the average values. So in the vertical direction, I've got a n delta t. Vertical momentum, which has been cancelled, is mv cos theta, because this guy was coming here with the velocity of v at an angle of theta with the vertical. Second, horizontal, you've got mu n delta t. I'm taking average. And the horizontal forward momentum, mv sin theta will get balanced. And third is the angular impulse. So basically, mu n delta t into the radius is r, and whatever is the angular impulse, that guy cancels the initial angular momentum, which was I omega. So omega was v by r. And what was the moment of inertia? It was m r square by 2. So I've got these three equations. If you look into this equation, like r will cancel out, and this will also cancel out. If you look into second and third, directly I'm getting mv sine theta is equal to mv upon 2. So I got theta is equal to 30 degree. Theta 30 is the first thing that I got. Now, what is the answer? Your answer to the question is the ratio of mu and theta. Well, theta I'll substitute as pi by 6. And I need the value of mu to answer the question. And mu I will get now. If you divide first and second again, so second divided by 1, you're getting mu. And that is coming out as tan theta. Tan theta, and theta is 30, so it is 1 upon root 3. So substitute this value 1 upon root 3. Now basically this becomes 6 upon root 3 upon pi. And 6 upon root 3 is nearly 3.4 something, 3.45 something. So you will get your answer. They have given 3.45 to 3.48. That is good.
So 16.
16. Okay, this was a nice question. I mean, in this paper, I liked it. And if you remember, in electrostatics, I have taken a similar concept. The only thing they have done is they have applied this concept of electro into gravitation, which is one and the same. So directly, if I can show you that small diagram. Yeah, look into this. He says that out of this hemisphere, I have taken out this small hemispherical mass here, from here. I made a cavity and placed it here. So for him, the system is like this. This guy is there and this guy is there. There is a cavity here and a mass here and a mass here. He says, find out the interaction between the two guys. I said, I'll observe it like this. I said, ki, whatever is the force that has been applied between these two, if I assume this force to be F, right? Force to be F. So this guy applies a force on the other guy, which is also F. Now I made a statement. I said ki the outer mass, if I connect another hemisphere having the same outer mass, I will have a full a sphere like this, having a cavity. But there's a property that within the cavity of a sphere, the field is zero. Gravitational field is zero. So what I did, hypothetically, I made extra mass on this side, right? And then I knew that because of this complete outer body, the force on the inner hemisphere is zero. But this guy was applying a leftward force F. So this will also apply a rightward force F because the net force on the inner guy is zero. Right? So I got those three terms. This guy applies a force F on this. So he applies opposite F. Now the outer complete system applies a zero force. So this means the leftward upper body applies a force of F on the inner body. Now this F is what is unknown for me. Then I thought, let me make a new system. Let me make a hypothetical inner complete sphere. And let me make a hypothetical outer hollow hemisphere. Now think, what is happening here? Here, there is an interaction between hemisphere to hemisphere. Remember, I am just solving this by the concept of electro. So I am showing all the forces to be repulsive, but we only need the magnitude of forces. So whether it is repulsive or attractive, that doesn't matter. So because the direction that I have shown is thinking that it is electrostatic. If you want gravitational, you have to just reverse the direction of the vectors. Answer will remain the same. So keep track of that point. So I thought, say, fine. This guy, if this guy on the left have a mutual F, so this will also have a F, and this half is also having a F. So basically, this sphere in totality applies 2F on this guy. So that guy applies a 2F on this guy. Now the concern was to find out the value of F. And 2F is what? 2F is the force applied by the solid sphere on the solid hemisphere. Solid sphere and solid hemisphere. Now life is simple. Now, if I have to find out the interaction of force between a sphere at a point which is outside the sphere, I can concentrate the complete thing at the center, the mass of the charge at the center. And then because of this, I'll go at a distance r and I'll cut a hollow hemispherical shell of thickness of dr. So that's what I did. Now check the calculation. So if I assume the inner mass to be m1, the field at a general r because of the mass is gm1 upon r square. So I've written the field. Then how to find out the force? So for force, I will use the concept of pressure. So I've written pressure into projection area. If I am at a distance of r, the projection area of that hollow hemispherical shell of radius small r thickness dr is pi small r square. That is pi small r square. And what is this term? So I have got an element dr. So the mass of that guy is what? Density into volume. Volume is 4 pi r square dr. Right? So this is the mass. So I have to write the force per unit area. And this is over an area of 4 pi r square. So I've divided by 4 pi r square. I think you understand why I've divided by 4 pi r square. Gm upon r square into rho into 4 pi r square dr. This is the total force on this hemispherical shell. But if you divide by 4 pi small r square, you get force per unit area. So then this becomes pressure, and pressure into projection area is the force. And then I integrated from r is equal to capital R by 2 to r is equal to capital R. I got my formula of F. Then life was simple. I had to substitute what is m1 and I had to substitute what is rho. Now rho was the density of the outer guy. Now remember, in the beginning only, we knew this thing, that these two guys who are present here, like this guy and the inner guy, their radius is 1 by 2. So the mass ratio was 1 by 8 kind of. So I said in the beginning, he said the total mass is m. So what was the ratio of the mass? This was m by 8. And this guy was having a mass of 7m by 8. Total was m. And volume was like r by 2 ka whole cube. So basically a factor of 1 by 8. Now, so if you want to write out the density function, everything, now you can observe, I knew all the data. So I just substituted my masses here to get my answer. Just observe what I have written as m1. You understand why I have written as m by 4? Because m by 8 and then hypothetical m by 8. So this term is basically 2m by 8. And you understand how I've written the density. Density is 7m by 8, the mass that I have written, and the volume is 2 by 3 pi. The outer radius r cube minus r by 2 whole cube is r cube by 8. You just liquid in the calculation, you'll get the result and you will get your answer as 0.7. It is the more important thing was to break the code of the problem. Once you understand the code, how to break the problem, you'll get your answer. Next question. Any other question? Paper 1, 2, anyone? Okay, nothing. Let's move on to paper 2 then. Let's go to paper 2. Yeah, paper 2. Problem.
Yes, sir.
Which one, Yash?
Sir, first one, sir.
First. Oh, that was nice. In first question, if I can just scribble small idea to solve the question. Yeah, this is what is happening in first question. From the left-hand side, a guy is coming down in a state of pure rolling. Look into the main ideas. Mass is m. Mass is m. He is saying ignore this radius in comparison to the radius of the inner surface. So I said he will roll down and he will move. So there will be a moment when it will come to the bottommost point. At that time, he will be having a omega. At that time, he will be having a velocity v. And his friend, the lower guy, will have an opposite velocity v because of conservation of linear momentum in the x direction. Now, the only problem here is how to write the expression of v and omega. So I said I have two equations. One is by the state of pure rolling. If you look into the condition, v minus the radius of that guy is small r. So v minus small r omega. So basically take r omega minus v is equal to v. That is the first equation. I've just applied the condition of pure rolling at the bottommost point. And second is by conservation of energy. So I directly said that this guy, center of mass has come down by radius capital R. So mg capital R is the increase. Increase is half mv square in this guy, half mv square in that guy, and half ICM omega square. And the body is a solid sphere. So 2 by 5 m small r square omega square. Just take care of small r and capital R. So here there is small r and here there is capital R. And I have ignored those terms, capital R minus small r, it is given. These two equations will yield you the value of v and omega. I have used the conservation of linear momentum and I have used the conservation of energy. I got my v and omega at this point. Now what will happen? After these guys reach, now it will try to go up, and this side of the surface is frictionless. Now, once it starts moving up on the frictionless surface, omega cannot change because there is no torque. So what will happen when it will reach the highest point? What will happen is it will have some omega, the same omega which it has got at the bottommost point in the same direction. Now, let's say this is my omega. And now, if this is the highest point, the relative velocity of this guy with respect to this guy is 0. Now, tell me one thing. Relative velocity means 0 means VREL is 0. Now, both of them can have common velocity. But if they will have common velocity, the conservation of momentum will fail. So basically, at this stage, when it reaches the highest point of its trajectory, the velocity of this guy becomes 0. And the velocity of center of mass of this guy will also become 0 at that point. Just keep track of this point. If at that state, this guy has some velocity in the horizontal direction, then center of mass will have the same velocity for this body, but relative velocity is 0. Omega it will always have at that stage because there is no friction. So if I assume the velocity to be some V prime, and this guy also V prime, because relative means both of them will have the velocity in the same direction, then only this relative is 0. But the only possibility to V prime is 0. Now the concern becomes how to find out the height. So what I'll say is, I'll extend this equation. Now I'll say that with respect to the initial position, if this position is y distance down, from the starting, if I conserve the energy to this point, mgy is the decay in the gravitational potential energy. And at this state, that energy is only seen as this term. Just write this term here. In the first go, there was no loss of energy, but second time when it will come to the bottommost point, I said, second time when it will go up, it will have impure rolling. Then it will come down. So that impurity will carry on. And that will ensure that finally, in the y direction, momentum in the y direction for the system finally is 0. So if you look into the A equation, he's saying that the impulse in the y direction will get balanced from initial to final state. So basically, the total impulse provided by the normal reaction from the ground and the weight of the two bodies will be equal. So A option is correct. Directly correct. Nothing to do. B option. Maximum height I have calculated. If you check, you can see it is not coming out to be correct. I've told you the concept. B. Now look into C and D parts. C and D part was based on the same concept. Tell me, first time when this guy crosses B, you have calculated everything. Then he goes to the topmost position. He comes down. When he reaches B second time. Now what happens here? Just analyze the problem again. At that instance, this guy is already having a omega, the same omega which we have calculated. There are some velocities these people have got. So I'll take my velocity. Let me say the velocity in the leftward direction is V double prime. Earth ke frame of reference. So if this will have a V double prime left, the lower body will have a V double prime right. Because the momentum in x direction is still conserved for the system. Masses are equal. Now, omega is already known to you. Y is known to you. Maybe you want the value of V double prime. I'm making a statement that V double prime, by conservation of energy, if I write all the terms again, right, the difference is kinetic energy term is going to come. And just compare those kinetic energy terms with this initial equation. Omega was known to you. If you write the energy term again from starting till this point, this term is same. This term may be V double prime here, but this term is same. So V double prime is equal to V. V double prime is directly equal to V. Now, if I know the velocity here, the question is, just as I cross B for the second instance, tell me what is the instantaneous power? Now, instantaneous power is basically F dot V. F dot V. Because of which force? That is because of friction. Tell me, if you look into this guy, your rotating guy, the bottommost point will have a velocity in the leftward direction, which is R omega, and a V double prime in the leftward direction. And if you look into the lower guy, there is a velocity of V double prime in the rightward direction. So friction, kinetic friction there will exert an instantaneous power, which is basically this friction here will act Fk, and on this guy it will act Fk. So power on this guy is minus Fk V double prime. And similarly, you can calculate the power here also. So if you want to find out the total net power delivered by friction at a particular point, on the system, you have to take the dot product of this Fk on this cylinder with the velocity of that point. Similarly, you have to take the dot product of friction with the velocity at this point. Take the total dot product. You'll have an expression of the negative power. That is your answer. You know the value of V double prime is V. You know the value of omega already. Now, what the question is only this much. So somebody will say, sir, how will we find out the friction at that point of time? So for that, friction, I'll write Fk is equal to mu, which was being provided into normal reaction N. So then it comes ki how will you write the normal reaction at that point? And definitely it is not equal to mg. So for that, what I'll do, I'll try to analyze the motion of our object at the bottommost point from the frame of reference of this wedge. So just observe the free body of that equation. I think all of you are clear about writing power, and then I will write the normal reaction and finish off the problem. So the power desired, net negative power at that point, is minus Fk into R omega plus V double prime and minus Fk into V double prime. This is my answer. Fk, I am already saying, should be equal to mu into N. Now my concern was the normal reaction. Idea is, at that moment, go into the frame of reference of your wedge. So wedge will become fixed and try to analyze the ball. Look into the forces on the ball. There will be a mg which is acting on the ball. There will be a normal reaction which will act on the ball. Normal reaction from this point, I mean point of contact, whatever it is. And left, right. So leftward direction, there is a friction which is acting here. Now, from the frame, what will happen? Once I go into the frame of reference of wedge, this point becomes fixed. But from that frame, the velocity of this guy becomes, I have taken V double prime, V double prime, V double prime, V double prime. So from that frame, his velocity becomes 2V double prime. So center of mass will have a velocity of 2V double prime. And it is moving on a circle of radius nearly equal to capital R. One more thing. I also need the pseudo force. Very interesting. But the concept is, at that point of time, if I look into the acceleration of the wedge will have vertical forces balanced and some horizontal forces are there. So from that frame of reference, on this guy, there will be a pseudo force. Because acceleration of the lower guy is horizontal. So there will be a pseudo force in the horizontal direction. But that does not matter because I need to write this equation. Neither this matters nor this matters. So my life is simple now. Np minus mg can be written as m. And from that frame, center of mass will have a velocity of 2v double prime whole square divided by r. This equation will yield you n at that point of time, which is required here. Np. Very interesting problem has been made thoughtfully and tremendous. I mean, it's a top 10, top 15 level problem. Anybody who cracks this problem in exam is sure sort like that. Very, very nice problem. I think all of you must have got the concept because this concept problem involves momentum conservation, energy conservation, instantaneous power, how to write instantaneous power on a system when impure rolling is coming up and translation is happening. And then when you're writing the equation for normal reaction, you cannot directly write mg. Neither you can write n minus mg is equal to mv square upon r because you have to go into the frame of reference of the wedge and then you have to take the factor of 2v double prime because they are in opposite direction. So the velocities will relatively get added. Then you will get normal reaction and your answer. So that is how you have to analyze the problem. Next problem in paper 2.
Sir, second.
Second. Let me just finish off quick. Yeah. This was like directly I'll tell you. What has happened is there's a ring which is given. This is conducting, and from the top view, you're like there's a point on the x-axis here, and then you go below this point. So if you observe in 3D, if I can give you that observation, it's like this ring, right? This ring. This with respect to a point from the center which is on the left, you go a little below that point, right? And this is a neutral conducting ring. And then we are discussing few things on the upper axis. What is that axis? Y-axis. We are discussing here on the y-axis. Now let me directly tell you A part. Electric field at any point on this y-axis, 0, R, 0, due to the induced charge on the ring is parallel. Tell me one thing. This is a conceptual question. Ring is neutral. Even after induction, the net charge on the ring will be 0. If the net charge on the ring is 0, tell me at any point on the y-axis, potential will be 0. And if potential is 0, that means potential is also constant. If potential is constant in the y direction, can there be any electric field in the y direction? No. If there is an electric field moves from high to low potential, potential has to change. But potential is not changing on the y-axis because of the ring, because it is neutral. So potential is constant, so field is 0. So A part is correct. B, the component of net field at 0, R, 0. Now tell me, if I go to this point 0, R, 0, you have to find out the net field, the component of net field. Can I write and he is already saying along the y-axis. I have already proved in A part that along the y-axis, the ring does not have any contribution. So basically, he is talking about the contribution because of the point charge on the y-axis at the corresponding point. So what you have to do is, forget your ring, just bother about that point, write the field on the y-axis at that point and take the component along the y-axis. Simple question. You understood this thing. Once you understand A part, B is very simple. C part, can you write the potential at point A and the origin? Let me tell you, potential because of the ring between these 2 points, 0, R, 0, 0, R, 0 and 0, 0, 0, the potential because of the ring at both these points is 0. So basically change the question. He says the electric potential difference. So my question will be electric potential difference between these 2 points because of the charge. So this ring was given to confuse you. Nothing doing in C part also. And what about the D part? He says the potential on the y-axis, the point on the y-axis where you will have the maximum potential. Tell me, the maximum potential will come when you are at the perpendicular distance. So basically, what you have to do in D part is you have to take the ring, you take this point, and from the point drop a perpendicular on the y-axis. And wherever is the perpendicular, the potential at that point because of the charge particle is the maximum potential because the ring cannot contribute in the potential at any point on the y-axis. So that question is like this. Idea is, even if the induction of charges on the ring is non-uniform, that non-uniform charge distribution, you may not find out potential because of that non-uniform distribution everywhere, but on the y-axis, because the distance of those induced charges from every point on the y-axis is constant and net charge is 0, that potential is 0. So potential constant, field 0 on the y direction. Then anything can be. So I've broken the code of the problem, then I think you can analyze the problem. Is this problem clear to all of you?
Yes, sir.
It is clear? Yeah, it is a nice problem. I think now what I can do is more discussion we will have because the next discussion of maths is coming up. I've already taken 5-7 minutes. Any remaining question, stick with the question. Tomorrow again I have a class at 8:30. I can take those 2-3 problems, whichever there, and we can carry on. So no worries. But just go through all these concepts that I have discussed today. See you in the class tomorrow, beta.